Hello everyone, you are welcome to my channel. I remain Mr. Life Changer, your tutor. In this very video, I am going to be focusing on electrolysis and everything that has to do with electrolysis, questions and answers, MCQ on electrolysis, and I will do well to touch on very important area, especially as regards your exams. Okay. Now we continue with the first one. Number one says electrolysis is best defined as A says the spontaneous decomposition of a molten heat. Well, we have many options here, but the answer to this question is B, the chemical decomposition of an electrolyte by passing electricity through its molten or aqueous state. Okay, so electrolysis is simply the decomposition of substances in molten form and in aqueous form, okay, as when electricity passes through them. Now the difference between molten and aqueous: molten simply means you melt it. For example, you can heat a salt to a particular temperature until it melts. It becomes, iron. It becomes liquid metal. The picture on my head is smelting of iron. If you have ever seen where iron is being melted until it becomes very hot and flowing like a liquid, that's what molten is. Then aqueous state simply means when it is dissolved in water. So when you dissolve salt in water, you get an aqueous solution. So electrolysis only happens when you use substances that are in molten form or in aqueous solution. Okay, that means when you use electrolytes. Now the next one says, which of the following correctly describes an electrolyte? Well, we have a lot of options here, but the correct answer is B, a substance whose aqueous solution or melts there means molten, conducts electricity and is decomposed in the process. I think we saw something like that earlier. Now that leads us to the third question. It says the liquid or solution through which electric current is passed through during electrolysis is called, of course, it's called electrolyte. Electrolyte is any substance that conducts electricity in liquid form, in molten form, or in solution. Okay, we are using different form. The liquid there means molten. Okay, that's very important. Now the fourth question says, in an electric cell, which component provides the driving force energy for the electrolytic reaction? The answer is C, an external battery or DC power source. Okay, or you can say a cell, a DC power source. An external battery is what produces an EMF around the cell. EMF simply means electromotive force, which is the driving force that drives current around a circuit. Okay, and that's the component of an electrolytic cell. Maybe I should help us here. An electrolytic cell is very simple in composure. It just has a container. It has an electrode which we call the anode. It has another electrode which we call the cathode. This is anode. And in an electrolytic cell, anode is usually the positively charged, and while cathode is negatively charged. Cathode is negatively charged. At this point, a lot of students have confusions here. Now, I want you to know that there is a difference between an electrolytic cell and electrochemical cell. They are not the same thing. They are two different topics. As a matter of fact, I'm going to be posting a video on electrochemical cell. So there's a difference between electrolytic cell and electrochemical cell. And one of the major differences is that in an electrochemical cell, the anode is negative, and while the cathode is positive. That means the reverse is the case. So when you want to know the charge of an anode and a cathode, the first thing you should know is what kind of cell are you dealing with. Are you dealing with an electrolytic cell or are you dealing with an electrochemical cell? I hope this makes sense. Okay, and another thing I want you to remember is that one of the major difference between an electrolytic cell and an electrochemical cell is that electrolytic cell converts electrical energy to chemical energy. That means through the supply of electric current, substances are produced, chemical substances are produced. Electrolytic cell is used to produce gases and metals, and sometimes some solutions. But in the case of electrochemical cell, another word for electrochemical cell is battery. You can call it battery, you can call it voltaic cell. Okay, you can also call it a galvanic cell. Okay, in this one here converts chemical energy to electrical energy. What that simply means is through chemical reactions within the cell, electric current is produced. That's why we call it battery. So these are two different types of cell. Don't mix it up. Okay, so in this case here, you have an anode attached to a cathode, and both anode and cathode in an electrolytic cell must be connected to a power source. This is the power source, positive, negative. And don't forget that the connection should be positive to positive, negative to negative. Don't forget that. Okay, even though this is called anode here, but here this is called cathode. This is called cathode here, but here in the cell, in a cell, this is called anode. Okay, then it has electrolytes. Electrolytes, any solution or liquid form, this is called electrolyte. Okay, now I did this to show you an overview of what an electrolytic cell contains. The major component of electrolytic cell, four major components. You have the battery or the EMF source. You have the anode and cathode, which are called electrodes. Anode and cathode all together are called electrodes. Okay, then you have the electrolyte. Okay, never miss that. That's very important. Now the fifth question here says the electrodes in an electrolytic cell are connected to the external power source so that the electrodes in an electrolytic cell are connected to the external power source so that the electrodes in an electrolytic cell are connected to the external power source so that now A says both electrodes carry the same charge. No. Anode is connected to the negative terminal and cathode is to the positive terminal. No. You can see my drawing. Anode is connected to positive, cathode is connected to negative. Then the C says the anode is connected to positive and cathode is to the negative. That is the answer to that question. Now, but I want to add something here. I want to say something here which is very important for you to note as regard this. Now, the electrodes, by definition, are conductors. That means they are especially solid conductors that through which current enters or leaves the electrolyte. They are conductors through which current enters or leaves the electrolyte. If you don't want to use current, you can use electrons. Okay, and I like to say this, that anode in the electrolytic cell, an anode is that electrode through which electrons leave the electrolyte. Electrons leave the electrolyte through the anode, but current enters the electrolyte through the anode. So always note that current and electrons always move in opposite direction. As a matter of fact, current is produced by movement of electrons, but current is produced in the opposite direction. Always note that. So you can say that anode is the electrode through which current leaves the electrolyte. Through which electrons leave the electrolyte, but it is also the electrode through which current enters the electrolyte. Okay, later you are going to understand why this is so. Okay, and in the case of cathode is the electrode through which electrons enter the electrolyte, or you say through which current leaves the electrolyte. There is how I remember it. So, and I'm going to show you that as we continue. Okay, so number 6 says, which of the following is not a component of an electric cell? The answer is C, a dynamo. In an electric cell, you have electrolyte, you have anode, you have an external DC source. What you don't have is an AC generator. That is very important. Now, here we come to electrolytes. The number 7 says, a strong electrolyte is one that, the answer, we have a lot of options here, but the best answer is A, is one that is completely ionized in solution and conduct electricity very well. Okay, so when you say an electrolyte is strong, it is strong because the ionization is complete. It completely ionizes in solution. And I would say that generally electrolytes are usually acids or liquids or bases, or salts. You can check out one of my videos. I have a video on acid, bases, or salts. You can go through them. You're going to learn a lot from that. Now, electrolytes can either be acids, bases, or salts. But when it comes to strong electrolytes, all these acids, bases, and salts, some of them are weak, they ionize weakly, and some of them ionize strongly. Okay, so those ones that ionizes weakly, we call them weak electrolytes, and those ones that ionizes strongly, we call them strong electrolytes. What we mean by ionizing is that they have the ability to dissociate in water. For example, sodium chloride, when it dissociates completely in water, you have sodium ion and chlorine ion. So when you drop an ionic compound inside water, water has the ability to split it into ions like this, and so you have NaCl giving us Na plus Cl minus. Now, but a weakly ionized substance like ethanoic acid is a weak acid. Okay, watch my video, or you can make demands. You can ask me to send you a video on this, and we always represent it like this: weakly is a very weak ionization, C3Oo minus plus H plus. That means they are called weak acids because they do not ionize completely in water. Not everything ionizes. It does not produce enough hydrogen ions. That's the difference. Okay, so that's by the way. So we have strong acids, strong bases. Strong acids, weak acids. We have strong bases, weak bases, and we have highly ionizable salts and non-highly ionizable salts. But I want you to note that the strong acids, the strong bases, the highly ionizable salts make up strong electrolytes. The weak acids, the weak bases, and the weakly ionizable salts make up weak electrolytes. I hope that makes sense. Okay, so the next one here says, which of the following is a weak electrolyte? I already taught you this. This is this. Okay, check out my video for soluble and insoluble salts, and you are going to see that copper sulfate is very, very soluble because all sulfates are soluble. H2SO4 is a strong acid. Sodium chloride, very, very soluble. That's what we use in cooking. Very soluble. You can confirm that. So among all of these, the weak electrolyte is CH3COOH. Very important. Now, the next one is distilled water is a very poor conductor of electricity because distilled water is a very poor conductor of electricity because it A, contains no dissolved ions. That is just simply the answer. Distilled water is a very poor conductor of electricity. It is not an electrolyte, and the simple reason is because it contains no dissolved ions. Now, don't forget that electricity is as a result of movement of ions, right? That is very important for you to note. Okay, so that leads us to the number 10 here. It says, at the cathode during electrolysis, A, oxidation occurs and cations are discharged. B, reduction occurs and anions are discharged. C, reduction occurs and cations are discharged. D, oxidation occurs and anions are discharged. Now, the answer to this question is C, reduction occurs and cations discharge. But hold on, I know you're going to wonder how. Now, this is how I know this, or this is how I remember this. First of all, whether you are dealing with electrolytic cell or electrochemical cell, oxidation always happens at the anode and reduction always happens at the cathode. So oxidation is a process that happens at the anode, and reduction is the process that happens at the cathode. So, and this is so easy to remember because this statement is true whether you are dealing with an electrolytic cell or you are dealing with an electrochemical cell. Okay, and you should also note that apart from this, when we come down to electrolytic cell, you should also note that in electrolytic cell, when current passes through the solution, there is a separation of ions. Remember that when an electrolyte is in the cell and current passes through the cell, the ions that make up that electrolyte will separate. Positive ions will go one side, negative ions will go one side. Remember that unlike charges attract. And usually anions always move to the anode. Anions and negative ions always move to the anode, and while cations always move to the cathode. You see that? So anions and negative ions, they move to the anode, which is positive electrode. Cations are positive ions, they always move to the cathode, which is the negative electrode, because unlike charges attract. So within the cell, you are going to observe that the ions, even if the salt was colored, you are going to notice that that color will disappear because of the separation of ions. One end is positive, the other end is negative. The negative end attracted towards the positive electrode, and the positive end is attracted towards the negative electrode, and all of that. That is a very important statement. We are going to discuss the discharge as we continue. So the answer is C. Now you see why it is C. Reduction occurs because it is the cathode, and cations are discharged because cations will always migrate to the cathode. Now, number 11. During the electrolysis of dilute sulfuric acid using platinum electrodes, the gas produced at the anode is I was not expecting this here, but let me say this. Now, at the anode, what is usually produced are gases. I'm going to just give a summary here for exam cases, for exam scenario. So gases are always produced at the anode because anions always give rise to gases. Now, and let me say this, except in one case, which you will see as we continue. Almost all the time, the gas that is produced at the anode is oxygen. And the equation, I'm going to give you the equation, but I will explain this as we continue. The equation looks like this. This is how oxygen is produced at the anode. Oxygen is produced at the anode because of hydroxide ion. The hydroxide ion in water, which I will explain later. Like I said, as we continue, I'm going to explain this. The hydroxide ion, would produce water and produce oxygen gas, then produce 4 moles of electrons. Now, but I like to say this, that at this point, just know that oxygen is always produced at the anode, except there is an exception. Except if the solution is concentrated, and for exam purposes, especially because you're writing WAEC NECO JAM, now the solution is concentrated, but not just that it is concentrated, it has chlorine, a chloride ion. Anytime the solution is concentrated and having a chloride ion, know that chlorine will be discharged or chlorine gas will be produced. Please note this. During electrolysis, oxygen is always produced at the anode. The only time chlorine is produced, for exam purposes, remember, like I said, the only time chlorine is produced is when the solution contains a chloride and the solution is concentrated. Like maybe you're asked to electrolyze concentrated sodium chloride, or you say concentrated copper chloride. You see, as long as it is concentrated and you have chlorine there, just know that chlorine will be produced. But in every other case, oxygen is produced. As we continue, we will know better. Okay, so this would be the end for this video. At this point, I'm going to continue the rest. There are 30 questions. I'm used to 30 questions. So see you in my next video. Thank you very much.